In this lesson, we will learn about factoring polynomials. Go ahead and write this in your table of contents and as a heading in your composition notebook. Before we begin, let's warm up with 4 problems. Pause the video, take approximately 10 minutes and try these on your own. Then come back and check your answers. Now that you're ready to check your answers, let's see what you got correct. So in number 1, I have 6 plus x squared squared. If you remember from the previous lesson, this is a special product rule. So if I remember that rule, I would know that anything that resembles a plus b squared is the same thing as doing a squared plus 2ab plus b squared. So in this case, 6 is a and x squared is b. That means that 6 squared goes here, plus 2 times 6 times x squared, plus b squared. Now take a look at b. b is x squared, then it's raised to another power 2. So you have to remember power to a power. You multiply the exponent, so I want to put this in parentheses, just to be careful. A little 2 on the outside. When I simplify, 6 squared is 36, plus 2 times 6 is 12, and then bring with it the x squared. Here, 2 times 2 is 4, so this would be x to the power of 4. Take a look, be careful because it's not in standard form, so this is not going to be my final answer. I want to rearrange. Then I would have x to the power of 4 plus 12x squared plus 36. Now it's in standard form. There's no combination of like terms, so this is all we're going to have here. Okay, now number 2. So number 2 is also one of those special cases. Now this time I have a minus sign. So if you remember the rule, we had a minus b squared is the same thing as writing a squared minus 2ab plus b squared. Remember, you don't have to use these rules. It's just a shortcut. You can still write the problem twice and do FOIL or box method. That's totally fine. But in this case, a is x and b is 8. So I have x squared minus 2 times x times 8 plus 8 squared, which would get me x squared minus, this becomes 16x, and then this becomes 64. No like terms, it's in standard form, so that's it. Okay, now, so number 3, I have a monomial times a monomial. So I'm going to multiply my coefficients and then add my exponents. 7 times negative 4, 7, 14, 21, that's negative 28. Bring my y with it, I have 5 and 2, that makes 7. On to number 4. On to number 4 is not a special case, even though I have a plus and a minus, but I have 2 different b values, 4 and 8. So I'm either going to have to FOIL or box or distribute, whatever you want to do. I'll do FOIL. First, x squared, out, plus 8x, in, minus 4x, last, minus 32. That brings me to x squared plus 4x minus 32. Okay, so let me know if you got 100%. And we're good to go. Let's move forward. So before we begin talking about factoring a polynomial and what that means, we first need to decide what it means to divide a polynomial. When I'm dividing, I have to remember my exponent rules. Remember, we learned in the little book of exponents that when you have a division sign, it's like a giant subtraction. So with the exponents, you're going to subtract them. My coefficients, on the other hand, I treat as normal. So for example, if I break this division problem apart, I have 18x to the 4 divided by 2x squared. 18 divided by 2 is 9. Subtract my exponents, 4 minus 2 is 2. Then my signs don't change. I have 10 divided by 2, which gives me 5. 2 minus 2 is 0. Remember, anything to the 0 power is 1, so I don't necessarily need to write that x there because I got 1. Then I have 6 divided by 2, which is 3, and 7 minus 2, which is 5. 3x to the 5th would be my answer there. If you take a look at this reduction, it's not in standard form. Hopefully you realize you would have to rearrange to get your final answer with the highest power in front all the way down to no power at all. So let's take a look at an example. 15. 15x to the power of 3 minus 10x squared plus 5x, all divided by 5x. The first thing that you want to do is break this apart into its own division problem. So I'm going to take 15x to the power of 3 and divide it by 5x minus 10x squared divided by 5x, and then plus 5x over 5x. The second step is to just simplify, knowing your exponent rules and how to divide the coefficients. So 15 divided by 5 is 3. 3 minus 1 gives me 2, so this will be x to the power of 2. Minus 10 divided by 5 is 2. 2 take away 1 is 1, so this will just be 2x. I don't need to put this exponent of 1 here, but just so you know, I'll put it. Then I have 5x divided by 5x. 5 divided by 5 is 1. 1 minus 1 is 0, so I actually don't need to put that variable x there since anything to the 0 power is 1. 1 times 1 is 1. Forgot my plus sign here. Okay, then I want to take a look. Is this written in standard form? Power of 2, power of 1, and then 1. So my last step here to write in standard form, it is in standard form, so my final answer would be 3x squared minus 2x plus 1. Okay, so take a look at these example problems here. Number 1 and number 2, give them a try, pause the video, and then check your work when you're done. All right, let's see if you were correct. So example number 1, you have 12a to the 5th plus 30a to the 4 plus 21a cubed divided by 3a squared. Break it apart into separate division problems. 12a to the 5th divided by 3a squared plus 30a to the 4 all over 3a2 plus 21a cubed divided by 3a squared. If I break this apart, I have 12 divided by 3, which is 4. 5 minus 2, which is 3. Plus 30 divided by 3, which is 10. 4 minus 2, which is 2. Plus 21 divided by 3 is 7. Then I have an exponent power of 3 minus 2, which is 1. So I just have a. You don't need to put that 1 there. Make sure it's in standard form. It certainly is, so I'm done. Okay, so example number 2 says 16y to the 5th plus 18y squared minus 4y all over 2y. Break it apart into separate division problems. You have 16y to the 5 over 2y plus 18y squared divided by 2y minus 4y divided by 2y. Simplify. 16 divided by 2 is 8. 5 minus 1 is 4. 18 divided by 2 is 9. 2 take away 1 is 1. I don't need to put the exponent of 1. Minus 4 divided by 2 is 2. 1 take away 1 is that 0 thing again, so I don't need to put the variable because anything to the 0 power is 1. 1 times 2 is 2. Double check, is it in standard form? It certainly is, and now I'm done. Dividing polynomials is an important skill to have before you continue on learning about factoring. If you need more examples, feel free to reach out so I can provide those for you. Before we move forward, ensure you understand what the greatest common factor is. If you're unsure about the greatest common factor, make sure you look it up before you continue. The first factoring we will look at is factoring monomials. Monomials is one term, so we're going to look at two monomials and find the greatest common factor that both of them share. The first example is 4yz and 2y squared. I want to break these monomials apart so that they're in the most simple form. 4yz, I'm first going to take a look at the coefficient 4. How can I break apart 4? Well, it goes into 1, 2, and 4. Since this bottom number has 2, I'm probably going to use the number 2 to break apart 4 because they have that number in common. So how do I make 4 out of 2? That would be 2 times 2. Then take a look at the variables. When you're factoring monomials, you only break apart the variables when they have a power. So both y and z only have a power of 1. That means there's only one y and one z. So the end of my problem here, I'll have one y and one z. Now for 2y squared, I'm going to break apart the 2. There's only one way to break apart a 2. It's 1 times 2. I don't need to put the 1. Anything times 1 is itself. So I just have 2. Now if you take a look at the y, this y has a power of 2. That means that this is y times y. There are two y's. So I have y and another y. In these expanded forms, I have some things that are alike. On top I have a 2 and on bottom I have a 2. On top I have a y and on bottom I have a y. So these terms I can pull out of the monomials because they have them in common. So if I circled 2y in both problems, the greatest common factor of both monomials would be 2y. My GCF is 2y. Next example. I have 12Q2 R3S compared to 3QR squared. So taking a look at the top one, I want to break apart 12. If I'm thinking about the number 12, what does 12 go into? 1, 2, 3, 4, and 6. Compare that with your bottom number. You're probably going to use the number 3 since 3 only goes into 3 in itself. How do I make 12 go into 3? That would be 3 times 4. I'm going to pause here for a second because I can now break apart my 4, right? 4 goes into 2 times 2. When I'm factoring, I want things to be in the most simple form. So instead of writing 4 right there, I'm just going to write 2 times 2. If we evaluate this, we still get 12. 3 times 2 is 6. 6 times 2 is 12. So I break things apart until I can't break them anymore. Next is the Q. You see how there's a squared? So how many Q's are there? There are 2. Q times Q. Then I go to the R. There are 3. So I should have 3 R's. 1, 2, and 3. How many S's? There's just 1. So you just write 1 S. Now the second problem here, I have 3QR squared. You can only write 3 as 3 times 1, so I'm just going to put a 3. There's only one Q, and there's two R's. Now circle what they have in common. The 3's, one Q, and two R's. So the GCF of these two monomials would be 3Q R squared. Since there are two R's, I can write that as R squared. Take a look at the examples number 3 and 4. Pause the video, try them on your own, then resume when you're ready. Okay, let's see what you got correct. So example number 3 is 16U4 VW. Then we have on bottom 8U4. All right, the numbers 16 and 8. 16 goes into 8. 8 times 2, right? 8 can be broken apart into 4 times 2, and 4 can be broken apart into 2 times 2. So really what I can write is just a bunch of 2's to get 16. Times 2, times 2, times 2. 2 times 2 is 4. 4 times 4 is 16. That's the most factored form of 16. Now take a look at your variables. You have u to the power of 4, so you should have 4 u's. 1, 2, 3, 4. 1 v and 1 w. Now if we look at 8, 8 is the same thing as 2 times 4. 4 can be broken apart into 2 times 2, so I'm going to write 8 as 2 times 2 times 2. If I double check that, 2 times 2 is 4, times 2 gives me 8, so that's correct. This is the most simplified form to write 8. Okay, the u. There are 4 u's, so I have 1, 2, 3, 4. Circle what's similar. 1, 2, 2 2's, 3 2's, 1 u, 2 u's, 3 u's, 4 u's. So my GCF of these two monomials would be 2 to the power of 3, u to the power of 4. 2 to the power of 3, I can simplify that. 2 times 2 times 2 is 8. So my greatest common factor would be 8u to the 4. Okay, example number 4. I have 15 m squared n squared and 25 m cubed n. 15, I can break that apart into 3 times 5. 3 and 5 can't be broken down any further, so I can continue. M times n times n. There's 2 m's and 2 n's. The number 25 can be broken apart into 5 times 5. I can't break apart 5 anymore, so then keep on going. M, 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 and N. Circle what they have in common. Looks like 1 5 and 1 2 m's. And also N. So the greatest common factor would be 5m squared n is the greatest common factor of these two monomials. Next, we'll look at how to factor a binomial. A binomial, remember, is 2 terms. So I'm going to take a look at the 2 terms and see what the greatest common factor is of those 2 terms. we want to find the largest monomial that's divisible by both terms in the binomial. Example number 1 will be 5x plus 10. Just like what we were doing previously, take a look at 5x and 10 separately. So we'll have 5x and 10. How can I break apart 5x? 5 is only divisible by 1 in itself, so I'm just going to write 5. There's only one x, so I can just write times x. The 10, on the other hand, can be written as 5 times 2. There's no variables here, so I'm not going to add an additional variable. That's how I could break apart my 10. If I'm taking a look, what they have in common is a 5. So the greatest common factor of 5x and 10 is 5. When we're factoring binomials, I want to take this largest amount, 5. It's divisible by both 5x and 10, so I can take it out of both terms. If I write this, I have 5 times x plus 5 times 2. If I write this as a distribution problem, I'm going to take this 5 and write it in the front of my parentheses. On the inside of my parentheses, I'm going to take the two terms it was divisible by, x plus 2. This is my factorization of 5x plus 10. Let's take a look at another example. Let's say I have 12x squared minus 6x. Take a look at these problems separately. So let's say I have 12x squared and 6x. The 12 can be broken apart as 6 times 2, but that can also be broken apart as 3 times 2. So I want to move that 6 as 3 times 2. Our next example will be 12x squared minus 6x. So take a look at them separately. I have 12x squared and 6x. If I break apart the 12x squared, I have 6 times 2 and then x times x. If I break apart the 6, I have 3 times 2 times x. I see something else. I can break down the 6. 6 can be broken down as 3 times 2, so I'm going to change that up here to make sure it's in the most simplified form. Circle what they have in common, a 3 and a 2, as well as an x. So the GCF of 12x squared and 6x would be 3 times 2 times x. In other words, 6x. So if I take out a 6x from 12x squared, you're dividing it. So I have my 6x in front. How can I make 12x squared? Minus 6x in front. How can I make 6x? Well, I know 6 times 2 gives me 12, and x times x gives me x squared. 6x and 6x are the same thing, so I know this is going to be just 1, because anything times 1 is itself. Take down what you have in common here. These are going to go in front of the parentheses. Change the color. 6x. And inside parentheses, you'll have 2x minus 1. If I check my work, I have 12x squared minus 6x. And you can see that's what you started with in the beginning. So when you have 12x squared minus 6x, you want to figure out what do the two terms have in common. Well, if you take a look at the greatest common factor, 12x squared broken apart, you have 6 times 2, but 6 can be broken apart into 3 times 2. and then there's 2x's times x times x. Then the 6x can be broken apart into 3 times 2 times x. Circle what they have alike. The greatest common factor is 6x. If I take out a 6x of my original problem here, 12x squared minus 6x, I want to figure out how can I get what I originally had. 6 times 2 gives me 12. X times x gives me x squared. Negative 6 times 1 gives me negative 6x. So inside parentheses, you take what you got as the greatest common factor in front, and inside parentheses you have what's left over in order to get what you originally had. The next example, we have x squared. Let's see, we have x squared plus 4x. Take these two terms, x squared and 4x, what do they have in common? The only way to write x squared is x times x. The 4 can be broken apart into 2 times 2 and then times x. Circle what they have in common, x and x. So the GCF of x squared plus 4x would just be x. If I take out an x from this problem, it's almost like you're dividing it. So I'm taking out the x in front of the problem. Inside parentheses, in order to get x squared, I just have x. Plus, take out an x in the problem. I have my 4x would be times 4. When I write my final answer, take the greatest common factor, the x, write it in front of your parentheses, and whatever's inside, x plus 4. If you distribute that, you would see that you get originally what we started with, x squared plus 4x. Lastly, we have factoring trinomials. You know that trinomials is 3 terms. So you probably know that it will be the most complex. Factoring trinomials is a heavy idea on the EOC. So it's very important you take your time to understand this lesson so you can be successful. Before we move forward, I want you to remember zero product property. Zero product property basically states if you have 2 numbers multiplied and the result is 0, one of those numbers must be 0 in order for it to work. When we are talking about factoring trinomials, we use zero product property to talk about the zeros of a function. When we set each solution equal to 0, for example in blue you have x plus 2 equals 0 or x plus 5 equals 0, you know that the solutions are negative 2 or negative 5 by solving that one-step equation. In the next problem, the same thing. We have x equals 0 or x plus 7 equals 0. Solve the one-step equation, you get x equals 0 or x equals negative 7. You can see how it's negative 7 if you use inverse operations, subtract 7 from both sides. So we're sort of combining this idea of solving equations, zero product property, and factoring trinomials to solve these type of problems. We know that if something must be 0, we can also solve the equation so that it says 0. That will be important later. So in our first example here, we have x squared plus 7x plus 6. So write down this example with me. We have x squared plus 7x plus 6. You may find factoring trinomials the easiest because I'm going to give you a tool that will really help you. In this problem, before we begin, you must understand that this trinomial has a standard form. ax squared plus bx plus c. You may have seen this before. In this case, in the example that I'm looking at, a equals 1, b equals 7, and c equals 6. It might be helpful for you to list a, b, and c so you know what I'm talking about when I'm using this strategy I'm about to teach you. So this strategy is called the umbrella method. The umbrella method, you're going to multiply A times C. So I'm going to multiply A, which is 1, times C, which is 6. So step number 1, multiply A times C. After you multiply, you need somewhere to put that number. So in this case, I have 1 times 6. Underneath your umbrella, it's not just floating in space. There's a guy standing underneath the umbrella in order to avoid the rain. So when I multiply, I'm going to put that number in the umbrella man. That number, 1 times 6, goes here. 1 times 6, hopefully you know, is 6. Now we have some other sections we need to fill in the umbrella man. First off, he needs something to hang on to. So we're going to drop this down here like it's the handle of the umbrella and put the 7. There's no addition, multiplication, anything. You're just dropping down that number B is what we call. So step 2, drop B. Multiply A and C, drop B. Now comes for the more complex part. I want to think of two numbers that multiply to give me 6, but add to give me 7. If I brainstorm those numbers, I want to think of two numbers that multiply to give me 6, but add to give me 7. The factors of 6 include 1 times 6 and 2 times 3, right? Which of these adds to 7? I believe 1 plus 6 is 7. So these are the factors that I'm going to use. Those go into the categories that are left. 1 and 6. Okay, so we're almost done here. How do I write my answer? Well, remember we're trying to work backwards here. So I'm trying to factor out something in order to write the factorization of this trinomial. If you remember using FOIL method, we had something written in 2 parentheses. After we FOILed, we combined like terms to get our trinomial or binomial or whatever we were working with. That's the same thing that applies here. We're working backwards to get that original problem. So if I write this out, I have my x squared, and then I still have my plus 6. But in between here, I'm breaking apart this 7 into 2 things, 1x and 6x. Where did I get those? My factoring, 1 and 6. As you can see, if I combine those together, I would get 7, and that's my original problem. Go ahead and group these things, x squared and 6x. Hopefully, after the practice of factoring binomials, you know how to find the greatest common factor of each of these groups. In the first example, what can I take from x squared and x? The only thing I can take is an x. What do I have on the inside? An x plus 1. Out of 6x and 6, what can I take out of it? The only thing I can take out is a 6. What do I have left over? X plus 1. What you have in parentheses should actually match. So how do I write my final answer? These things that you factored is going to be one set of parentheses. X plus 6. The things that match, you're only going to write one of them, and that's going to be important when we get into more complex examples. X plus 1 would be my answer. So this is factoring trinomials. Let's take a look at another example. Let's say I have, x squared plus x minus 2. starting from the top, I want to multiply A times C. That gives me -2. Where do I put it? Down here. Then I want to drop down my B value. Multiply A times B, drop down, multiply A times C, drop down B. Multiply A times C, drop down B. What is B? Is it X? No, it's the number in front of X, 1. Then I want to go to my chart and figure out what multiplies to give me -2, but adds to give me 1. So now we have a negative number here. In this negative number, I want to make sure that my factors represent that -2. So we're going to have more than what 2 would have as factors. So for example, I can't just write 1 times 2 because that's not -2. I have to make a number negative in order to get -2. So let's say -1 times 2. That would work, right? What else do I have? I have 1 times -2. I can make the 2 negative, and that would be it. Then I want to see what adds to 1. Well, -1 plus 2, that's 1. 1 plus -2, that's -1. So which factor am I going to use here? Probably this one, since it's the solution for both columns. In my umbrella man, you have -1 and 2. Now breaking apart the problem. So remember, we have x squared plus x minus 2. I'm still going to have my x squared, and I'm still going to have my -2. However, now in the middle, I've broken that x apart into -x and plus 2x. Okay? Then you're going to group the first 2 terms and the second 2 terms. Then you're going to factor. So I have x squared minus x. They both have an x in common. I have x minus 1 would give me that solution. Plus 2x and 2, they have a 2 in common. How do I get that? X minus 1. You know you've done this correctly when your parentheses match. So you see an x minus 1 and x minus 1, they both match. How do I write my final answer? Take these 2 terms here, x and 2. That's your first parenthesis, x plus 2. And then take what you have matching. You only need one of them. Here is factoring my trinomial. That's example number 2. Now let's go to example number 3. Example number 3 says x squared plus 11x plus 30. Back to the top. Multiply a times c, drop down b. A times c is 30. Drop down b, which in this case is 11. 2 numbers that multiply to give you 30, but add to give you 11. Okay, this might take me a while. I have 1 times 30. I have 2 times 15. I have 3 times 10. I have 5 times 6. Anything else? I don't think so. Then figure out what they add up to. Since they're both positive, I don't have to worry about what I had to do in the previous problem in listing the same factor set twice, because I'm not trying to get a negative number. In this example, I'm working with positive numbers, so it's a lot simpler for me. 1 times 30 is 30. 1 plus 30 is 31. 2 times 15 is 30. 2 plus 15, 17. This gives me 13. Ooh, bingo, 11. So what am I using? 5 and 6. Those go on the side here. Okay, so I know how to break apart my problem. Remember, you started with x squared plus 11x plus 30. So I'm going to have the first term, x squared, and still I'm going to have 30. Now to break apart of the 11, I have 5x and 6x. Group, factor. Okay, between x squared and x, all I can take out is an x. How do I get that? X plus 5. Plus, what can I take out of 6x and 30? This may take you a moment to think. Well, 6 actually goes into 30, so the greatest common factor would be 6. X, and how do I get that? Plus 5. Hey, look at that. My parentheses match, so I'm good to go. Write these ones first. So you have x plus 6. And what matches in parentheses only needs to be written once. Okay, here is my factoring of my trinomial. Next example. Let's take a look at x squared plus 13x minus 30. Hopefully you're repeating this back with me. A times c, drop down b. A times c, drop down b. Now work it out. Two numbers that multiply, multiply to give me negative 30, but add to give me 13. Hey, I've already listed some of the factors of 30, right? But now this time I have a negative 30, so be careful. Something has to be negative. Negative 1 times 30 or 1 times negative 30. Then I have negative 2 times 15 or 2 times negative 15. I also have negative 3 times 10 or 3 times negative 10. I also have 5 times 6 or 5 times negative 6. Okay, so which of these adds up to 13? Well, that would be negative 29 or positive 29. Whoops. This one would be negative 29. This would be 13. I think I have a winner. You can keep going if you would like, but I know this works, so I don't need to do extra work. Right, here's what I'm using. Negative 2 and 15. Remember, you'll still have your x squared and you'll still have your minus 30. What goes in the middle is negative 2x and plus 15x. Go ahead and group, and find the greatest common factor. What can I take out of x squared and x? I can take an x out. What do I get in the middle? X minus 2. What can I take out of 15 and 30? How about 15? Plus 15, that would be x minus 2. Okay, so I'm going to take the first terms, x plus 15, and the second, inside parentheses, I only need one of them, x minus 2, and that is my factoring of my trinomial. In my next two examples, they are slightly different than what we've been working with. Let's say we have x squared minus 8x equals negative 12. In the previous problem, we didn't have any equals. So when you see that equal sign here, there's usually going to be a follow-up question, and I'll get there at the end of this. First, we need to remember that standard form I gave you. ax squared plus bx plus c. Right now, I don't have that. I have A, I have B, where's C? You need to rearrange this into standard form so that the negative 12 can be moved to join the x squared minus 8x. How do I do that? Well, you remember solving equations, you can move the 12 by inverse operations. So if it's negative 12, to move it, I need to add 12 to both sides. Notice here it does not have any like terms, so I'm just going to write it as standard form. We have x squared minus 8x, and this becomes plus 12. Equals, where'd this go? Well, you can put equals 0, and I'll tell you what that means at the end of this. Then we have our umbrella man. Hopefully you know a times c drop down b. A times c is 12, b in this case is negative 8. Go to your chart, two numbers that multiply to give you 12, but add to give you negative 8. Little bit of a different case. Factors of 12 include 6 times 2, 2 times 6. I also have 3 times 4, 4 times 3, 1 times 12, and 12 times 1. Why did I write them if they mean the same thing? Well, if you take a look in the add column, add to negative 8 is going to require me to do something very specific. If I have a positive 12, critically think right now, how do I get a positive 12 when I multiply? I know a positive times a positive is a positive. I know that a negative times a negative is a positive. So perhaps these situations will be negative. Negative 6 times negative 2, negative 2 times negative 6, negative 3 times negative 4, and so on. I need to make all of these negative. Why? Because I need to get a negative 8. Now combine. Same signs, add and keep. So this will be negative 8. I think we already have a winner. Or here we also have negative 8. Here we have close, negative 7, negative 7, negative 13, and negative 13. So how do you decide which one to use? It doesn't matter. It's the same thing. It'll just change how you factor at the end. I'm going to go ahead and pick this first one here, negative 6 and negative 2. How do I write that? You have your x squared, you have your plus 12. In between, I now have negative 6x and negative 2x. Group, factor. So between x and 6x, I can take out an x, and that gives me x minus 6. Here I can take out, I can take out a 2, so minus 2, and that would become x minus 6. Remember, I want these to match, so that can sometimes help you figure out what should go in that last parenthesis. This one was kind of tricky because I have that negative 2 here. So if I take out the negative 2, then I have to be careful that this sign is correct. Remember, when you work backwards, if I distribute, I should get what I started with. Okay? If you have any questions about that, feel free to reach out. So here I'm going to keep going. Remember to take what's in front. So I have x minus 2 and then x minus 6. That would be my factoring of this trinomial. Okay, let's look at another example. Oops, I'm not done yet. Back to here. It equals 0, right? Back up, change this. Something different. It equals 0. So what does that mean? Because in your assignment, it may ask you this question. Well, if it equals 0, that means one of these things must be 0. So I can find a solution by saying x minus 2 equals 0, or x minus 6 equals 0. If I solve this one-step equation, plus 2, I have x equals 2, or I have x equals 6. So your assignment report may ask you to state the solutions of the polynomial or the trinomial, and this is how you would find it. If you notice, it's actually in the solution here. It's the opposite signs. So here you have x equals 2, and here you would have x equals 6. You don't have to do all of this work here. That's just to show you how I got that answer. So if it asks for the solutions and you have something that equals 0, it's asking about that zero product property. Set them equal to 0, and you can find the solutions. When we get back, we'll take a look at how that looks on a graph as well. Let's look at another example of these equals questions. So next example will be x squared minus 2x equals 15. Remember, we want this in ax squared plus bx plus c form. So in order to do that, I need to move the 15 to put it in its place. How do I do that? Well, this time I have a positive 15, so to move it, inverse operations would be to subtract it. My new trinomial becomes x squared minus 2x minus 15. Umbrella man, multiply a times c, drop down b. So a times c would be a negative 15, drop down b. Two negative numbers. So you're going to find, how do I multiply to get negative 15, but add to get negative 2? This will be tricky. I have 1 times 15, 15 times 1. Since I'm dealing with a negative number here, one of my numbers needs to be negative. So negative 1, negative 15, let's say 3 times 5 or 5 times 3. Okay, one number has to be negative in order to multiply to get a negative number. Then I'm going to add all these until I get negative 2. This would be 14, so that doesn't work. This would be negative 14, so that doesn't work. This would be 2, so that doesn't work. And this would be negative 2. So my last solution is the one that I'm going to use. Negative 5 and 3. In the previous problem, it didn't really change which one I used as negative, but this does, right? So make sure that you have that correct. Now, if I keep going here, I'm going to have my x squared and then my negative 15. In the middle, I'll have negative 5x and then plus 3x. Group, factor. Take out an x, I have x minus 5. Take out, I think you can take a 3. Notice how you have a plus sign, so this isn't as complicated as the previous one. Plus 3, and the inside I would have x minus 5. Remember, you want these to match here, what's in parentheses, so that sometimes helps you figure it out. Take out what's in front. So I have x plus 3, and then inside parentheses, x minus 5. Remember, this equals 0, so what are the solutions? If you're just taking a look, remember I told you you can just inverse the sign. So my solutions would be negative 3 and 5. Or use zero product property, x plus 3 equals 0. Or x minus 5 equals 0. If I solve this one-step equation, I would have x equals negative 3. Or plus 5, x equals 5. And there's my solutions. Okay, so those were the examples for this factoring trinomials. If you need further examples, feel free to reach out. Otherwise, go ahead and try these 3 problems on your own. If you want the answers, go ahead again, reach out, and I can provide those for you for these 3 questions. Otherwise, you can also quiz yourself with the 3 questions provided here. And again, if you want the answers, feel free to reach out. This concludes my presentation on factoring. I've added additional videos here, which I'll provide the links below, and you're welcome to watch those if you need some further assistance.